Hey there, welcome back friends. In this video we will try to understand how to create a thread by extending the thread class, and this is fairly straightforward. In order to understand the concept, first of all we will create a class by the name of myCounter, and we will create a private property inside this class. This variable will be used in our program definitely, and we will give the name as thread number. Alright, now let us quickly right click, navigate to source, and we will generate the constructor using field. And using this constructor we will definitely initialize the thread number variable. Alright, now is the time to create a method now. Now what exactly this method all about? We will give the name to this method as count me, and definitely as the name suggests we will add some counter mechanism in order to understand what exactly we are processing, and we will display some information, some message inside this loop. So this loop would be a for loop. We will initialize I as 1, we will increment till 10, and we will increment the value of I. Alright, now let us quickly add some message in here. The message would be the value of I is, and we will simply display the value of I, and then definitely moving forward we will also display the thread number. Now take a note of it that the thread number is initialized by taking help of the constructor. Alright, so this looks good to me. Here we go. Alright, so this is good. And now moving forward, inside our main method we will call in the countMe method. Now definitely in order to call in the countMe method, first of all we need to create object. So we will create the object as myCounter counter1 equals myCounter, and we will give the thread number as 1. We will repeat the same process. This time we will give the object name as counter2, and we will initialize the thread number as 2. Pretty standard straightforward process. And using the counter1 object we will call in countMe, and again using the counter2 object we will call in the countMe method. And in between these two methods let us quickly add in a separator. Pretty standard stuff. Now let us try to run this application, and in fact I suppose there is something going wrong. Alright, there is this issue inside our for loop. Let me fix it. Let me give the condition as less than equal to 9, and now here is the output. Perfect. Now friends, check out the output. Firstly, the thread 1 has finished the entire process. It has displayed the statement 9 times, and then definitely the thread 2 has completed its entire execution by displaying the next 9 statements, and in between there is a separator. There is no multitasking which held when it comes to the usual type of programming. Now let us move forward, and now let us try to extend our class by taking help of our thread class. Alright, so now moving forward, let us quickly try to extend our myCounter class, and we will definitely make use of the thread class which is provided by default by Java. Alright, and now let us also do one small little thing. As the execution is very fast, we will add a sleep timer. What exactly is a sleep? It will stop the process for some specific time, and we will give the counter as a value of 10,000 milliseconds. Now let us quickly also use the try catch block to surround the sleep method call, as the sleep method will throw an exception. Now let us quickly run this program, and alright, so I guess the sleep time is way too much. It's 10 seconds. That's a silly mistake. Let me convert it to 1 second, and now every 1 second we can see a statement which is on the console. So this is the process. This is how our program is running, which is interesting in fact. Alright, so this is good. Now moving forward, let us convert the sleep time to maybe 500 milliseconds. That would be good. And now let us do one small little thing. Let us try to calculate the total amount of time required for the entire process. This is fairly straightforward. So we will create this start time variable. This is a long variable, and we will make use of current time millisecond method in order to get the current time. And then we will again use the same statement, use a yet another long variable. And if we would like to calculate the total time required for the entire process, we can simply subtract start time from end time. So it would be like total time required to process equals end time minus start time, and we will get the time required for the entire process. Fairly straightforward. Alright, so now let us quickly run this application. And in total there are 18 statements, and per statement we are taking half a second. So in total the time required is just above 9 seconds. Take a note of it. Remember the total time required, it is about 9 seconds. Now let us override the run method. Now this run method is already there inside the thread class, so we can override it, and inside this override method we will simply call in the countMe method. Now friends, as we are calling in the countMe method inside the run method, so consider the entire logic of the looping inside the run method. And the run method is very important, as we have already seen in our previous presentation. And now moving forward, instead of calling the countMe method, we can simply call in the run method. And now let us check the output. Now definitely when our application is running, definitely we can easily make out that the first thread with number 1 is getting executed first, and then thread with number 2 is getting executed. This means there is no impact of the thread class, or there is no multi-threading application going on. Run method should be called by JVM instead of ourselves. That is the reason why it is happening. What is the solution? Definitely we need to call in the start method instead of this run method. This is something which we have already discussed in our last presentation. So now as soon as in place of run method we call in the start method, then we would be able to see a drastic change in our overall application output. Let me show you. So in here, first of all, we can check the jumbled up output, and the total time required to display these 18 lines is showing 1 millisecond, which is definitely wrong. And the reason why we are getting this output is very simple. The reason being, now thread 1 and thread 2 are working simultaneously, and they are independent. Our application is indeed a multi-threaded application now. Once we start the program, main thread will start and end, but thread 1 and thread 2 will continue, and they will work together and display us this result. Now let us move forward and do something extra in here in order to understand the scenario even better. Alright, so now let us quickly do one small little thing. Let us add a sleep timer on the main method, on the main thread as well, so that we can stop the main method to die. So we will add the sleep timer of 500 milliseconds or 5 seconds, and it will give us the total time process is around 5 seconds, which is okay. But in fact the total time which will be required is around 4.5 seconds, or just slightly more than that. Why? Because overall, if we remember the total time required earlier, it was 9 seconds, but now as we are processing the entire process simultaneously, the total time required will be slightly more than 4.5 seconds. Alright, so now let us give the value as 4501 millisecond, and if we get the total time statement at end, then we were successful, and if the statement is in between, which we have got, this means that the time 4501 millisecond is insufficient. So let us increase this value. So we will give the total time or the wait time to be 4505 millisecond, and I suppose this time should be enough to process these 18 lines. These 5 millisecond is nothing but the exact time required to process the data, and 500 millisecond, 500 sleep millisecond is the exact time which we have added in the loop. So now let us try to check whether this will work for us or not. And I suppose this should work. 5 millisecond is good enough time to process 18 statements. Alright, so this looks good. Now friends, let's proceed further and discuss a couple of more things related to multi-threading. In here, when we execute this program, the main method will get executed. Now when we are executing the main method is nothing but part of the main thread. Now as the other threads, counter 1 and counter 2 has some sleep mechanism, the threads have some idle time. As a result, all the statements which were there in the main thread were getting executed right away. And this is the reason why when we comment out this statement of sleeping the main thread, we were not able to calculate calculate the total time required for execution. It is taking some time to show you the output. Let me show you the output. Here we go. So because we are not sleeping in the main thread, as a result, the first thing which our program is doing is calculating the total time. As a result, the total time is 0, right? So let me uncomment this. Now why we are for example printing these statement in a other sequence. We have thread 1, then thread 2, then thread 1, then thread 2. Why there is a jumbled up sequence? Let me discuss on that. Now the reason is pretty simple. As soon as the counter 1 thread will get executed, there is a sleep time, that is the ideal time. The hardware will not waste any time and it will start the yet another counter 2 thread. As soon as the counter 2 thread will start, in the first iteration itself, the counter 2 thread will again go to the sleep mode, right? As a result, the counter 2 will also enter a ideal time. Now at that time, there is no work for the program itself. After half a second, the thread 1 will resume its execution and it will print the statement. So likewise, for every iteration, firstly the counter 1 thread first iteration will take place, then counter 2's first iteration will take place, then counter 1's second iteration will take place, then counter 2's second iteration will take place. So whenever there is a ideal time, the hardware will try to utilize hardware in the best possible manner. Now whenever there would be an ideal time, the JVM, the hardware architecture, the operating system resource management, and the resources which are available to the thread would be utilized in the best possible manner. If there is no work, JVM will start some other work if there is some other work available in the memory. Pretty simple, right? Now friends, if there is any confusion in your mind related to threads and you are not able to understand 100% what exactly I am trying to convey, that's okay, because multi-threading is comparatively little complicated than other concepts. That's okay. Take a leap of faith. You will get these concepts later down the line. Start programming, start experimenting, and also try to research more on internet related to multi-threading, because this concept is a little complicated to understand, I accept, but you will get it over the period of time. Moreover, we have the whole lot of videos, a complete section dedicated to multi-threading, and many more videos will be released in forthcoming days. So don't worry, everything would be covered, and do practice. That is very important. Thanks for watching. Take